to you about tonight, and thank you, Andrew, for the chance to come and have a chat about this sort of stuff, is I'll probably leave it for others to talk about the problems, and I kind of give you guys the benefit to understand what the problems in this industry around security are, right? So the account harvesting of devices, that kind of thing. I want to try and present a solution to how we're going to handle security in IoT, how we're going to manage that as you connect out to back-end systems, right? So whenever I say back-end systems, feel free to think about our back-end system, but I won't talk about that tonight. This is more about an extension we've done to our identity product. And saying that, so has anyone seen a Salesforce presentation before? Everyone seen this slide? Okay.
Got more words in the article.
Yes, it does. So this is something my lawyers compel me to say. But actually this is really important tonight. What I'm going to talk about is stuff that does not exist on our platform in a generally available manner today, okay? So this is a pilot feature that's coming in our next release. Like, yes, we will be we'll be moving forward with it, provided it all goes well. We do not guarantee that what I'm going to talk about is going to be generally available. So I want to kind of frame this in this discussion on this is how you might architect these type of solutions. I'm going to talk a lot about standards-based identity, and these are standards that our engineers have actually authored. A guy named Chuck Mortimer, if you want to follow that guy on Twitter, he's awesome. Kind of co-authored this kind of stuff with some of our engineers over there. So any purchasing decisions you want to make tonight, do not make them on anything based on any word I say in the next 30 minutes, okay? Make them on generally available functionality. Okay, so that's the lawyers, I have to say that. Okay. What's really interesting for this whole IoT thing for us at Salesforce is this concept of what's behind that device. Okay, so a lot of people talk about, you know, the Internet of Things being sensors and smart cities and all this kind of cool stuff that, you know, people like us get really excited about. And it is, you know, we put the propeller hat on and away it goes and it's fantastic, and, you know, charts and sensors and, you know, lots of terminals with data streaming and all that kind of stuff. Looks really great, right? But I think one of the things that's sort of lagging in the, I guess, the business value behind this technology is this concept. Okay, behind every device, behind every sensor is a customer. Okay, now that customer might be the owner of that machine, okay, that you've got sensors on. That customer might be the person that you're, you know, tied a Fitbit onto, or some kind of wearable, or some kind of people counting sensor or whatever. And that's key for us, right? Is to be able to, we talk a lot about this thing we have at Salesforce called customer centricity, right? So customers are the center of everything. And we've kind of extended this to IoT, and this is the journey I want to take you on tonight about how that works and how we do that securely, because there's a few standards-based things that security means for us. So I want to introduce you to the Salesforce platform. We call this architecture. It's pretty nice. Are there any SEs in the room, by the way? Nice. Cool. And what I want to talk about is I guess this layer. So this is our platform. This is the stuff that I talk about every day. So we have a bunch of identity services on the platform today. Let's put IoT for one side because it's just an extension of this sort of stuff, right? So we do single sign-on, two-factor authentication. So Salesforce works, and again, those of you that raised your hands before will probably not know this, right? So Salesforce works on the internet as a fully functional, featured, extensible cloud identity solution, right? So we can be a service provider to the internet, or we can be an identity provider to the internet. Okay, so we integrate all with, you know, I was talking to the Microsoft guys before, we do an excellent integration with their Azure Active Directory, and does that just-in-time provisioning and that identity store. And this, what I'm going to talk about tonight, is kind of an extension of that, where we sort of move that, we're not managing a user or an app identity anymore, we're actually identifying a device and tying that back to a person, and how do we go and do that? So what are some of the challenges when we start to think about this kind of stuff, right? Now, it's interesting to frame this from our software engineer's point of view, where we can only control what we can control. So if someone builds, you know, an unsecure, I don't know, call it a Jeep Cherokee, we can't control that. Okay, so what can we do on our side that when that device becomes compromised, or, you know, how can we assure and prevent the compromising of that device, and how can we then, if it does get compromised, how can we limit that and kind of firewall that on our platform so it can't kind of spread and infect others and stuff like that. And we do that with, like it's basically an OAuth job bearer flow, so an OAuth token. We're going to talk about how this works. This is a kind of a new standard that we've co-authored. So this is that whole concept of we're not managing things, and we're not managing people and apps, we're managing things. So what needs to happen to these tokens to make this interesting and to make it sort of viable for the wider market? So first they have to be open. So open, self-describing and contextual. These security tokens must be open because, like I said, we're going to build these things so they can connect to back-end systems. And they have to connect to multiple back-end systems. We're not going to build this proprietary so it just connects to Thunder. You can go and connect to any back-end system you want. Okay, and it has to be based on standards. And we're huge with open source and with standards at Salesforce. So to give you an idea of, I guess, just how much we support open source, last year our engineering team, they're very proud of this, we've had our first project released as a tier 1 Apache project. Okay, it's called Phoenix. It kind of applies schema to NoSQL, but don't worry about what that is. But that's the sort of, we support the open source industry. We contribute to a lot of products. So it's going to be open source standards based. The tokens need to be self-describing and they need to carry context, right? So these things need to operate autonomously from the Salesforce platform. So we're going to give the device a token. It needs to have metadata inside that token that says, I am this device, here's my ID. So we can use that ID to identify the customer on our side, but inside those claims that live inside the token, we're going to be able to use that to actually prove proof of ownership of a private key. Okay, so if you have verification of manufacturer private key on your device, so getting back to the Jeep Cherokee thing, the way those guys hacked or started the original exploit on that was they downloaded a VM of the console, the entertainment console, and started sort of reverse engineering it. Google, if you're very interested in this, and I am, they've actually published their paper. You can download the paper and read it, and they tell you how they did it. Anyway, for those of you that know, the chipset they compromised is also in Ferraris. Anyway, so these tokens must be long-term and they need to be high scale. Okay, so again, it's this whole concept of this thing needs to be autonomous. Okay, so you need to set it up, register it, and then walk away. And then that device now starts pinging your back end and doing what it needs to, okay? Scale for us, we talk about scale a lot at Salesforce. To give you an idea, the Thunder platform, today we sort of talk about a 24-hour window of 5 billion events per customer. And again, I'm sort of not giving anything away to the internet here, because we've spoken about a Dreamforce. We've got a hard goal requested by a customer for the end of this year at 50 billion events in 24 hours. Okay, so scale, when someone from Salesforce says scale, that's the numbers we start to talk about in this sort of thing. Yeah? Okay, well, it needs to have delegated constrained authorization. So this is that whole concept of if that device gets compromised, it can't really do anything outside of its limited authorization. Okay, so we know about, this is what the OAuth bearer flow does. So we have authentication, bang, you're authenticated with a platform. I have a token that now lets me act on behalf of a user or an asset or a machine. And that authorization that's described in the token says I can go and update this record only. And if I can't kind of get around that, right? So I've kind of ring fenced and I've firewalled that thing pretty good. It needs to have what we call a spectrum of assurance, right? So a people counter in a shopping center, which is like a little tiny sensor, it's not going to have the hardware on it, and it's not going to be worth building that sensor just with a full private key, cryptography, check this key, that kind of stuff. So it needs to just be able to, here's an ID and this is who I am. Or if we're putting this into a medical device that, the risks and the consequences of compromise are much more severe, then it needs to have this level of assurance that we can actually write. And the tokens need to be able to support that. And last but not least, and this is probably the most important for us, and not for, I guess, the reason that you probably think, but it's integrated with CRM, right? And you think about why that is, and get back to that, behind every device. And this is where I get really passionate about this sort of stuff. So the value out to people in technology is not like all of us in this room, we're all technical people, right? So we all have these conversations about technology to other people, and they just look at you like, really? That's excellent. And it's not until you can say, okay, here's the value to you as a business owner, here's the value to you as a CEO, why you should do this, why this is important, and that's actually identifying the person behind the device. So that's pretty important to us. So talk about standards. We are standards based. These standards apply to all of our identity products in Salesforce. Okay, so we support SAML. Not only do we support, we contribute to these and we author these. So we're co-authors of the OAuth 2 SAML, OAuth 2 bearer tokens, what we're going to talk about tonight, and SCIM 1 and SCIM 2, which is this cross-domain identity management protocol. So you can start to pass attributes around of users, and we use this sort of stuff to do just-in-time provisioning and stuff like that off the platform. So we talk about, you heard me talk about being an identity provider or a service provider on the internet. So you can authenticate with your Active Directory, single sign-in into Salesforce, click on a tab, and that creates an account in Gmail or Dropbox, and have all that managed from your Active Directory. And that's what I mean with, that's how we start to do all this kind of stuff. And we won't talk too much about that. Okay, so introducing our asset token. This is what we're calling this stuff. Before I start, I'm going to put that little. This one's got a really good one. It's like, this is not generally available and we can't guarantee it. But so the whole purchasing decision things again. But here's how we've done it, right? So we're going to secure the device interactions with your back end. Okay. Everything I've spoken about. But the important thing here is this adapt to your business. So because it's built on Salesforce, and again, you have that customization behind it. So you can have a device and you can actually add your own custom features and your own custom attributes to it, and then we'll have a look at how that works in a minute. And it'll actually come through into the token, and we can do stuff and trigger business processes off it. And that's that whole, you're now in an automated platform where if someone registers a new device, you can trigger an action off that registration. Okay, we do it to create the asset connected to the customer. You might want to, something simple, send a welcome email. Okay, again, very easily done on the platform. So what the asset tokens provide, so open source JOT-based token. I don't know if you've got an insomnia problem, go and read the standard. But it's based on open standard stuff. The interesting thing about it is easy to work with for humans because it kind of makes sense, and we'll have a look at that in a second. But it's also nice and compact, so it'll fit on these tiny little sensors and these devices and stuff like that. Okay. Automatically integrated with Salesforce, so that's obviously important for someone from Salesforce to talk about. But what that does is it allows the dynamic creation of assets. So get back to that question of scale, right? So if I've got a Fitbit in the market, or a Nest thermometer or something, and I want to sell 1 million of these things, do I really want someone to ring in and register with my support center for 1 million devices? No, I want that to happen automatically. I want that to be registered. I want that to just link into my customer and just happen automatically, okay? And I want that to do that at scale. So it brings extensibility and platform integration. So again, this whole bit, we can actually put in these extra attributes. But again, these things are all now queryable instantly in the API. So you've got other programs and stuff like that need to interact with them. One of the things that we do from our API piece is it becomes a really nice integration hub in the cloud. Okay, so you can start to connect all types of systems. Again, all open standards based, that kind of stuff. And probably most importantly for this audience, we can do this signature and proof of possession. So this is how we start to move into, we talk a lot about defense at depth. Okay, so multi-layered, how do we defend against stuff? So you actually now can request that this device has a private key or a verification of manufacturer, and then cryptographically, that's probably not even a word, thank you very much, go and actually verify that that key is correct, okay, and take action upon that, okay? So, maybe let's stop talking to that device. Let's send a notification back to your back-end system to deregister that device because it's been compromised. And of course, log a case and all that kind of stuff and notify someone as well. Okay, so how does this work? Well, we're going to go through an example of basically a thermostat interacting with that device through an app on a mobile phone. Okay, so think of your Fitbit, right? You get your Fitbit, you register it with your phone, you talk to it and kind of set it up. The phone could be your back-end service. It could be some other kind of application. Okay. So it's first thing we have to do is register it. Doink. Okay. My PowerPoint slides. There we go. Okay, so the first thing happens, the user authenticates to the community. Now we're just talking about normal, standard Salesforce authentication. What this app is doing is it's going to hit Salesforce and get an access code. So I want to talk to the API. We'll actually then pair with the device and collect the metadata from that device. Okay, so that could be, as you see there, the private key coming back inside the JSON Web Token. And now we register that application, that device, with Salesforce. So we go into the Salesforce platform and we actually register that this device has come online. The automation inside Salesforce now creates that asset. Okay, the metadata inside the token that comes back from the device contains information, about who the customer is, what the serial number is, all that kind of stuff. So we have that registration. And then we can use tools like our process builder or our flow engines and actually do stuff based on that. Again, think of a welcome email. It's a very simple use case. And then we issue the asset token back to the device. Obviously through the application, or for this audience, this probably makes a lot more sense to you guys rather than my pretty pictures. But that's kind of how it works. And then once we get down here, we've got asset tokens, and we start to do this public key request and response to do a verification now that this thing is saying, here's my token, bang, into the device backend, come back to Salesforce. The interesting thing about securing all this with Salesforce is, you get this world-class compliance and all this kind of stuff that comes with it. And it's not a security and compliance discussion, but check out trust.salesforce.com for that sort of stuff. Okay, so this is where it's going to get really, really interesting. Wow, that's a JSON Web Token. Easy to work with, right? So remember the bit about easy to work with for humans? 3 simple parts. So some header information, the magic, so that's the payload, so that's going to have a whole bunch of claims from the device in it. Okay, so what am I signed with? What's my ID? What's my serial number? What's my customer ID? That kind of stuff. And the signature. Very, very simple stuff. Let's decode some of these things, right? So we'll decode the header. So you can see here, I've got a key ID. What type am I? So I'm always going to be a JOT. I'm always going to be signed RS-256. So this key ID assets is actually something you build inside Salesforce. So it's a key that you generate on the Salesforce platform, and the device back end can start to use this key to verify that this thing's who it says it is. Okay, so you can start to call the APIs in Salesforce and say, okay, I've got this key. Can you actually tell me that this is that this thing's actually who it's pretending to be, which is pretty cool. Inside the claims, so we've got stuff like an audience. You can set, not before and expiry times. This is for that proof of possession stuff. So it's called a confirmation claim. There are probably others in the room that know a lot more about this than I do. But that's the piece that says, here's my private key. Okay, here's something I've signed with this private key, and you can actually go and verify that this exists. Okay, the ID of the device, expiry dates. That is a Salesforce ID. That 18 character string. Okay. So that's actually telling the thing, this is an asset that I know about on Salesforce, and the device ID if you want to get that sort of stuff. Very simply, you notice now this connection is no longer there. You connect directly to your backend service. The backend service identifies the asset token and now talks and takes action on behalf of the customer. Okay, and that's a really important point. And that gets back to that whole OAuth bearer token, right? So I am now only authorized. This device is only allowed to do what that OAuth token says it's allowed to do. Okay. And there's a couple of different ways you set scopes inside Salesforce, but it might be able to read the API and it might be able to talk to the asset, and that's it. And then you leave the automation tools inside Salesforce to actually handle all the other process stuff that you want to handle in a business process. Okay, which not only sort of adds that extra layer of security to the whole system, but it lets the business analyst type, the SME people, start to build the process out on what goes on with the platform. How this might look with Thunder, I mean, that's a pretty picture. That's kind of us just saying, well, that would be how our backend would sit in the middle of it. Okay, so our backend service is this platform called Thunder. You would actually, register the device. The asset token gets passed into Thunder, and then that verification happens with Salesforce. And again, the interesting point there is it's a registered customer, it's a recognized customer, and it happens with the registered asset. Okay. So, what I want to do, how am I going to have time? Just yet. I want to have a quick demo on this sort of thing, right? So we've built a little. I'm going to step you through how it works now. I'll be the first to tell you. So this is an identity demo. This is going to be the most boring thing in the world, but we sort of built this thing out to go and show you how this stuff works. In a real world scenario, you would actually go and validate this against the community. You can do it against a Salesforce org, but we've got a little. This is Fix Coffee Importers. They're a company that exists purely in all of our imagination. So we're just going to go and specify. We're going to walk through the login process. Am I still on the internet here? Yep. Cool. Now, this is my client ID. So inside Salesforce, I don't know if any of you guys have worked this kind of stuff with Salesforce. We have this concept called a connected app, and this is where we start to apply limited scope to these things. So I have a connected app, and you see here it's given me a key and a secret, so I'm kind of generating this kind of stuff inside Salesforce. I've actually given it an asset signing certificate, so I've generated the certificate on the platform. So this Heroku app here is simulating the mobile phone app, right? This is what's going to happen in the logon flow. So we're going to log into the community. Here's an example of the URL to log into the community. Now this passes into our OAuth login flow, which is going to ask me for donk. Okay, so that's kind of just our identity product at work. And so now we have an authorization code. So the way the Salesforce login flow, you hit a login server for the entire platform, and then it responds with a code and another URL. So okay, here's your access code, go here and hit this service. So we're going to go and hit that service and exchange the authorization code. As I said, guys, very boring. This is just me logging in. So I'm now logged in, great. Okay. So what happens now is I've actually got to go and, what we call mint the asset token, right? So I've got to go and pass some information into the platform to say I need an asset token for this device. So you give it basically we're going to build what's called an actor token, which is another JOT, which will explain this kind of stuff, what's in here as well, right? So what I'm going to do, which I would know from my contacts, is going to get a contact. So I'm going to tell it, who I'm logged in as. That's fine. And asset name. Xpand. Happy days. And I've got this here. So this is the device generating a private key. I'm going to sign this thing, and away I go. So I'm going to build my actor token. Okay, so sort of what we were talking about before, we've got the header, the payload, which is the JSON object itself, and then the signature. Okay, so the header is telling me it's a device key with this algorithm, and there's the information in it, right? So there's the name, the serial number, that kind of stuff, and my confirmation claim. So I'm going to go and request my asset token. For those of you, when we release this kind of stuff, feel free to go through and have a look at all that stuff. It's large strings of text. So actually what I do want to show you in this, so I pass it my access token that I got when I logged in, okay, and I'm going to pass it my actor token. Now the trickiest bit about all this is actually building that actor token. Okay, so building that JSON object that you pass in that describes your device. Great, asset token. Okay, so interestingly now it's come back, it's put another value into the header. So this is that the key ID, which is, I can go in that, I won't go back into that, but that was the Adam's assets, the key that I've generated on the platform. So again, in your device backend, you can now hit the Salesforce platform with this key and say, okay, I want to look at this key and I want to sign this and I want to have a look and decode that. And here's all my payload and stuff like that on the device. And you can see, I've given it an audience and an issuer. Okay, so again, we create this relationship between the device and the platform for that multi-layered defense. Now, let's go and have a look at our. And you'll see, create a demo, guys. Come on, internet. Anyway, so we've created a connected asset. There we go, and there it is. There's my asset. Now tied to that customer, and so now I understand I can actually do stuff based on that inside the platform. Okay? There is standards behind for refreshing and that kind of stuff, so you can set your token limits, all that sort of stuff. So that's it. That's kind of how, one of the ways that we're going to look at solving this whole, for us, this security problem is about identity, fundamentally. And security on the platform for us is about identity. We bring our kind of world-leading security that we do, and we just bring it out to everything we release. So the IoT will be no different, but using that kind of standards-based token flow, that's one of the ways that we're going to propose to actually handle this security issue that's out there today with IoT.
Thanks, Adam.
Thanks very much. Any questions?
You said you'd offer the identity management as a web service, so will that be available to utility companies and others who want to take up the...
So again, he's asking me about product, I'm going to talk about product. So we have a product called External Identity. So you can be a user of Salesforce and do nothing else but manage identity. And the spring release, which is coming out on February the 13th in the APAC region, actually includes storage and API calls and access to accounts and contacts just for identity. So yeah, absolutely we will. You want to talk to me about that later? It's interesting because I know there's some legislation. You mentioned utilities, right? So there's the smart meter legislation coming in the New South Wales government. I think they'll put it into Parliament at the end of March, and that's huge.
Yeah, there was a massive problem in Norway with a sewage company who are getting sued into the ground at the moment because somebody hacked a pumping station.
You want to secure that?
Yeah, it made a very big mess.
Yeah.
And there's a lot of utility companies here who are very scared and looking for ways of solving the
and it's interesting, right? Like, so I talk with a lot of APRA-regulated customers, right? So that's the level to which we secure, and defence and US government and that kind of stuff. So we are certainly well equipped to have that conversation. Yeah.
Anything else? We're going to take a quick 5-minute break before the Microsoft guys are also set up. But thank you very much, Adam, and I'm sure we'll be around for a few questions later on. Cheers. Okay, ladies and gents, just before I introduce our two chaps from Microsoft, the thing I forgot to mention at the start is we are streaming tonight, so if you don't want to get in front of the camera, then please don't. If you're asking questions to the group, can you just speak up a little bit, so it's quite hard to hear at the back. Now we've got Lee and Dave from Microsoft, who are non-technical to technical.
It's true, and I've got a story to back that up, so that's fine.
So I'll let these guys start. We'll do Q&A afterwards, and then we'll go from there. Thanks, guys.
Thanks, Andrew, and appreciate everyone's time. So what have we got? 30 minutes? Same as our friends at Salesforce. So we've got a session today. Hopefully not as well. Do we have demos? Do we have demos? No demos. But lots of pretty pictures. What we want to talk about is looking at IoT from an enterprise perspective. So kind of thinking forward to where IoT is going to start landing in real deployments, real customers, real scenarios where you guys are going to use it. So we want to look at some of the challenges of enterprise scale IoT as opposed to necessarily some of the sort of the nitty-gritty details of it as it is today. As Andrew so eloquently pointed out, yes, I'm the non-technical, I'm the product manager for our Azure IoT products here in Australia. To give a little context and to kind of verify that I actually used to be technical, although it will also prove why I should never be technical again. Back in 2002, I was working for RSA Security. I was an SE, a solutions engineer. I've forgotten it's that long ago. And at the time, it was actually, if you know, it was at the point where the RSA algorithm was going to, the patent had expired. We were very terrified about what was going to happen to that expiration and who was going to do what with it, and when our tokens become useless. And I got caught at a conference. I don't know what the conference was. I got caught by a journalist who said to me, "So what's your commentary on the RC5 64-bit algorithm? You know, what's the risk of it being hacked?" And I sat there, no media training, a bit of an idiot, and I said, "Oh, look, if you throw enough monkeys at a problem, you're easy to solve it. I mean, anyone can do it." So if you now type into Google, Lee Hicken, RSA monkeys, forever, sit flying down, it will say that quote and it will live on forever. So 2 lessons there. First of all, never, ever put me in front of media. Yeah. Secondly, tell your kids what you put on the internet stays on the internet forever. You cannot get rid of it. So that is unfortunately my claim to fame. I'm the guy that tried to badly quote Douglas Adams and got it wrong. Dave, introduce yourself.
So yeah, I am the technical guy. So my name's Dave Glover, and I've been around Microsoft now for 22 years. And absolutely love it. And over the last, I've kind of done a lot of work around embedded systems, web systems, done a lot around mobile and obviously Windows, and we're doing a lot around the cloud nowadays. Most of my focus over the last couple of years around IoT has been a lot down in the kind of building stuff. It's kind of sort of touching on the makerspace and kind of from there up into the cloud. Now, I don't claim to be a security specialist, but I do know enough to be dangerous, and we'll talk about that as we go through. So anyway, that's kind of about me.
I'm CISSP certified still.
I'm not even sure what that means.
Anyway, so let's get on with the story. So, this is a building slide, isn't it? Let me let this build out. So, lots of stories, lots of problems. Everybody here, I would assume, is patently aware of the challenges that IoT is hugely scary. And we're going to hack my car. I've got a Jeep, by the way. I heard the story. I've got a Jeep. Thankfully, mine wasn't one of the ones that was hacked. It's good to know how it was hacked. But there's a lot of furor. There's a lot of kind of concern that IoT is just the new gateway for risks of exposure from hacking. I guess one of the things that our perspective on this is, and one of the things we're seeing is, IoT is becoming this collision point between. Sorry, before I say this, anyone's a hardware engineer in the room? Good. Hardware engineers, God, they're causing all the problems that we have in IoT. They don't know how to write good code. No. But it is this collision point between hardware engineers and software developers. And it is this, hardware engineers by definition have always considered themselves to have to work in a glass bubble. They don't have to think about the connectivity. They never had to. Most hardware build products were built once, lock it away, it never connects to anything, it never gets updated, it never gets touched. We don't have to worry about it. So things like clear text passwords, things like HTTPS, things like security overhead are not things they think about. And so I'm not suggesting that necessarily all of the things that you see here and the problems we're seeing about IoT in the market are driven by inadequacies of hardware engineering. I'm just hinting at the possibility that that's part of the problem. And until hardware engineers and software engineers kind of meet in the middle, a little bit like the channel tunnel connection, and when we hit that point and we shake hands with the French, we'll figure it all out. But that's where we are today. So that's why we're seeing a lot of these challenges, because we're dealing with people that have not had to deal with security, trying to build some very, very secure products. We haven't solved that problem, but we're certainly going to talk about what we think we can do to help solve some of those problems. So we've talked about who we are and what we do. We're going to talk about Microsoft's vision, strategy, a little bit, not too much architecture. Thank you for that phrase. I like to use that as a marketing manager. That's great. Thank you. We're going to talk about open source. Now, this is an unusual engine for us. I've been at Microsoft 10 years, you've been 22 years. Normally when we say open source, we spit a little. Like, you're just going to get it out because it's hard for us to say it. But we love open source. We do. We do. All right, a couple of stats for you to take away, so just so you know. Worldwide.
Official stats.
These are official stats. Okay? Are you quoting me on this?
Yeah, you're on record.
But as I pointed out earlier, you never put me in front of media, and I'm a marketing guy. I read this on a slide the other day. So worldwide, 22% of our Azure VMs, in Azure, by the way, is our cloud service, if you please, hopefully you know that, are Linux VMs. In Australia, 37% of our VMs. We love Linux. We are really happy, proud, excited to enable Linux
You're
environments.
happy to sell a platform that hosts Linux. That's great.
I would add a bit to that. If you're familiar, do you have .NET developers in here? We had historically. So .NET now has pretty much wholesale been open sourced out to the community, and absolutely. So we're seeing all that work that we've done going out with the open source community. There's a whole Mono project which is .NET, which is .NET on Linux, which has been around for a long time. That now is in the process of emerging. So we're taking, in fact, the open source community taking the best bits out of Mono and the best bits out of .NET and merging those together. So that is fundamentally the Microsoft platform, the application development platform, has all gone open source. And you'll find a lot of what we're doing is very much driven by open source. So sure, we're running open source on our Azure platform, but fundamentally across the board, we're doing a huge amount around open source. So just have
It's a very good point. So anyway, I'm taking along on this intro slide. But what we're really going to spend most of the time on, and I was saying me, we, and Dave, we're going to talk about our IoT security layer of principles and models in our cloud strategy and our device and thing strategy from an IoT perspective. So Dave's going to drill through that. And then we're going to wrap up, we're going to talk about Stride from a process around analyzing and looking at the threat model in an IoT solution. I'll talk a bit about kind of our approach to how we do it and share that with you. You can take it away if you like it, use it. If you don't, fine. But we have an approach that we'd like to share with you. So I'm sharing data that's not mine. So first of all, you can't criticize the data itself from a Microsoft perspective. It's not our data. But what it, and you can read the information. I don't need to read the data out to you and the dots points there. What we know is today, when we look at IoT devices, there are a litigated list of issues around how they're being built in terms of very simple problems, like not even having passwords, weak credentials. They're vulnerable to very simple attacks, lack of transport encryption. They're just being built in very simple ways. Now, as I said, we don't necessarily come to the table here today to say we've solved some of those problems, but what we're building and what we're thinking about is a platform that enables you to, in some way, enforce some of the good practice that needs to be pushed down to device manufacturers. And we'll talk a bit about what we're doing from a Windows 10, from our perspective of what an IoT enterprise class device should look like, but then also, I guess, how we're taking those principles and making them available to a broader open source, Linux embedded, real-time operating system type market to ensure that there's some consistency of that. Because that's one of the key principles from a security perspective is consistency of code, consistency of protocols across the devices and the infrastructure that you're connecting to. So we're going to look at threat modeling, and as I mentioned, that Stride model, and determining the risks, figuring out where to spend your money on solving problems and where to not spend the time and efforts on where we think the least risk of exposure is. And that varies depending on what is the device, what is the outcome, what is the business value, what is the solution you're trying to design. It's one of the key issues that I'm finding from a product management perspective in IoT is IoT doesn't mean anything. It's a horrible phrase. It just defines this amorphous idea of things connected to things delivering some kind of value at the end of it. The things could be anything from a $2 Bluetooth sensor to a car or a $50 million pump in a BHP Billiton gas facility. So it could be anything. So the value and the risk and the investment around what you model as a threat varies very heavily based on the hardware, the device, and the price point of what that device is. We're going to talk about updates. So again, thinking about this from a hardware perspective, when people have built hardware devices in the past, updates are not a consideration. You build it, you ship it, you use it, and then it's done. In the world of IoT and enterprise class IoT, suddenly updates become important. We want to keep evolving the product. We want to keep adding features, we want to keep changing features, we want to be on top of that. So how do we think about updates from an enterprise class in an IoT model? I think Dave, this was your point, but you really can't secure something you can't update. Security is not a fixed point. You can't ship something and say it's secure forever. It will always be changing. The threat matrix always changes. So you need to be able to update it. Communications becomes a really key part of this. The whole value proposition of IoT is devices that are out there in unusual and disconnected places, but we want to be able to connect them back to a service of some kind, and that feeds into that cloud piece. Now we're not going to spend, I don't think we're going to focus too much on cloud security per se, but we're going to think about think about field gateways, think about devices, think about connecting them to the service platform that's going to be consuming that information to make some value out of it or derive some value out of it. These are all the moving parts you've got to consider. You can't look at IoT as just about securing the device or securing the identity or securing the gateway. It's an end-to-end complete process. And so with that, we kind of break it down to 4 zones of IoT security that we need to think about, and Dave's going to dig into more deeply. So we think about the device. What is the device? What's it doing? What data is it holding? What data is it transmitting? How often will it connect? How does it connect? Over what protocols? Over what gateways? All these questions need to be answered and figured out to assess the risk and how that threat should be mitigated. Is it going to go through a field gateway, or is the device going to connect directly up to the service platform? And if it's going through a gateway, now we're aggregating many devices. We're talking about protocol conversion. We're talking about aggregation of data. Maybe we're doing some on-gateway processing of that data as well. Fundamentally, it's all going to feed its way up through a transport protocol. And we're going to talk a bit about some of those protocols, what they mean and how we leverage them. But one of the interesting things about the IoT world is because it's basically right now, it's the wild west of IT, these transport protocols are many and varied, and there are a few emerging standards, if you like, MQTT, AMQP, and others, but there are also lots of other ways that things are being transmitted over devices, and we're still dealing with devices that are transmitting over serial and RS-232 type ports as well. We're going to factor all that in. And then lastly, at the end of the day, you're building all of this, you're connecting things to the service for a reason, to create a service offering, to create some value, to create some information out of that data, and how we're protecting that layer as well. So, that was a very high level view.
That's great.
Dave, if you want to dig into some of those parts, please.
Okay, thank you. Okay, so I was going to kind of drill through a bit about kind of what I see as some of the issues. So the first thing I was going to talk about was devices, and you could class devices into 2 or 3 parts, but I'm going to do it kind of pretty simply. There are a huge number of cheap, small devices out there in the marketplace that are potentially doing IoT, which fundamentally don't have the capability to do security. They can't do SSL, they can't do TLS, they can't do managed certificates, they can't go and compute things. They simply don't have the footprint. So that's a huge class of those. I'm going to talk a bit about what we're doing with that starter device kind of a bit further on. The first thing I'm going to talk about, though, is the starter device, which I guess I'd class as enterprise-style devices, where enterprises are typically going to be securing a higher value asset. So that's kind of fundamentally where this is going. So the first one I'm going to talk a bit about is what we're doing around something around Windows IoT core products, and just give you a bit of a flavor. So if you remember on Lee's slide, a lot of there was things like firmware hacks and all those sort of things. Someone could come along and physically change the firmware, maybe put in a bootloader or a keylogger or whatever it is, into these types of devices and start hijacking them. So to give you a sense of what we're actually doing around trying to prevent certain types of attacks, there are things that we're putting into IoT Core which will go into very small devices, but enterprise-style devices. So things like secure boot. Is anyone familiar with what secure boot is on Windows, in the Windows world? So a few of you are, a few are not. So secure boot, and it kind of drives a lot of this UEIF standard, is around really having digital signatures on all aspects of the boot loading process. So all device drivers, the kernel, all those components of drivers, all those types of things have a signature on it. And with secure boot loaded enabled, only the drivers that have been signed that live in that chain of trust will actually load. So the whole idea behind that is obviously to stop people going and putting in bogus drivers into a high-value IoT device, and then maybe having that data being shipped off to somewhere else. So that's very much around what are we doing around this kind of whole issue around firmware. Stop somebody coming along and hijacking the actual device. The other aspect of these types of devices is what you can do around kind of offline attacks. So okay, I'm going to grab the device, I've got the device in my hot hand, it's offline now, I'm going to pull it apart and now start digging into the SD card and things like that, or whatever the storage is on those particular units. Now again, you'll be familiar with BitLocker on Windows, and it's the same technology that we put into the IoT core that's there to encrypt all local data. So again, someone might have whipped it off and then now try to pull it open and try and figure out what's going on with that device. That data is encrypted, so they will not be able to get actually access to that data.
For example, with a VM that you've had mentioned. VM's encrypted, doesn't matter if you've got a copy of it, it's not valuable data.
Yeah. And that is held, and if you're familiar with something called a TPM, which is a trusted platform module, I think it is. And that's there about maintaining the keys. Often they're burnt in at the time of manufacture of that device. We also support something called measured boot. And again, this is coming all the way down to IoT devices. And this is where you start thinking about enterprises who want to manage an enterprise scale IoT device. So this gives the ability of an administrator to be able to dig into that machine and basically ask it what its boot history was, what actually came up, what certificates were signed, what drivers are loaded, all that type of information. So you can have a high degree of trust that what's running on that machine is what you put on it, all the way down to what you sign and put on those applications out there as well. There's obviously things like Windows Update, and I'll talk a bit more about that as well, but that's going all the way down to the smallest of devices. And again, that's something that an enterprise would be able to manage in the same way that organizations do today, in terms of being able to manage the flow on of those updates out to the systems. Obviously, the power of these devices in terms of enterprise class devices, they do have the compute power and the memory power to be able to go and do more sophisticated encryption algorithms and deal with certifications and certificates, all that type of thing. So be it storage or communications, all those libraries, all that capability is built into what we're shipping out with Windows IoT Core. From an application perspective, I know we get quite carried away with kind of what's in the platform, but most of us who are software guys will know that some of the biggest hacks actually happen at the software layer, and it's because we've often done something pretty daft, and maybe there's different standards across the platforms, and our developers are all doing things like that. So most of you, if you've done kind of .NET, you'll understand managed memory, and what we're doing around universal platform is really around managed memory, and that's to prevent things like buffer overruns, all those types of things. So the things that when you're developing really small devices, you often develop in C or C++, those are the kind of things that can start running amok, and someone can attack. Obviously, we're trying to do things like buffer overruns and things like that. And obviously signed applications. So it kind of gives you a bit of a sense of what we're doing around the platform, so that you could go out and put an enterprise style device out there with a great deal of confidence that you know what's going to be running on that device. So I've kind of touched upon this already, but we have a number of IoT SKUs. So I don't want to go too much into product, but just to kind of give you a bit of a sense of what we have out there. So today, and kind of, you think about all these security things I've been talking about, these all ship inside these versions of Windows. So these are versions of Windows that would typically ship to an OEM. You wouldn't go and rock out there and buy one and put one on your PC. And these would be things like the process control system, where you really care about security, you really care about the reliability of the components, and there are a whole raft of manufacturers out there who build systems that kind of like deal with these types of capabilities. We have something called IoT Mobile. And IoT Mobile, think about it as kind of point of sale, or you're doing stock take, or those types of devices out there which you're kind of dealing with those. And the lowest kind of level down here, which is what I'm going to talk about a little bit more, because this is the kind of platform that you'll typically embed and put into, into a lorry or a truck or a high value asset, or run a water system on it, or whatever it might be. This is something called IoT Core. Now, just to be clear, with the Windows, with what we're doing around universal platforms, they all run the same kernel. They all pretty much run the same version of Windows. And IoT Core is a free of charge license. It's the things that you might have seen around Raspberry Pis. So if you're familiar that we now have Windows 10 running on Raspberry Pis on the ARM processor. But I'll talk about what other platforms are out there as well. So we have IoT Core, which as you can see is targeted at small devices, but it has all the things I mentioned before around secure boot, BitLocker, all those types of capabilities. The ARM processor has enough capability to deal with security and make sure that those types of things are managed. We also have something called a Pro version, and that version will go out to OEMs. So it's not the kind of thing you download and put on your Raspberry Pi. It's the folk that are building out bespoke, building out solutions which they take out to market, and they'll be running a version of Windows 10 IoT Core. And to give you a sense of what we're doing, and again I'll kind of talk a bit more how this works. So with IoT Core, which I said is this free of charge license, which runs all these security things I've just been talking about, we have the Raspberry Pi, I'm assuming most people are familiar with a small device out there. What I should point out is all the devices here I'm talking about are developer boards. They are not the type of board that you would go to market on. So you would go and prototype on them, and you'd come up with the solution of your dreams, test it out, and then you would go to a manufacturer and say, maybe 100,000 of these, or maybe whatever it is that I'm going to deploy in all my trucks worldwide. So these boards here I'm talking about are developer boards. So we have the Intel chip as well, and today the developer board is something called the MinnoNow Max board. And it has a built-in TPM chip in there, so it has all the security in there, being able to do secure boots, all those types of things. And the other board out there is the Qualcomm board. And again, they have Wi-Fi and Bluetooth and storage and all those types of things. But the heavy emphasis on this, what I'm showing up here are developer boards. When we're building Windows 10, we build it to the system on the chip specification. And then we go off to the manufacturers, the Altec and all those types of people out there. And these people out there build these enterprise class devices, and those devices will be running IoT core, and then solutions will be built around those. So that's very much what we're doing around the core and the platform, and what we're doing around security to make sure that you can deploy those devices with confidence. How many people here have heard of AllJoyn? Few hands. Okay, going up. Okay, so AllJoyn's kind of interesting. So what AllJoyn is, and it's getting back to this open source kind of thing again as well. AllJoyn from the All-Seen Alliance is actually, I think it was rated this last year, as the most successful open source project. And its goal is to deal with the problems of interoperability of IoT devices. So go hunting around for it. And it's been driven by the Linux Foundation. And we have absolutely taken that specification, we've worked with those standards groups, and we have implemented the AllJoyn into Windows and Windows 10, all the way down to Windows 10 for IoT Core, all the way down there. You can get AllJoyn libraries for Android, for iOS, for Windows, for Linux, you name it, for Mac, etc. So it's very much a standard about how do you go and discover services out there that you want to connect to, how do you interop with them, but particularly around identity, which I think was picked up on the session before. So it's very much about how do we do this kind of cross-platform interoperability. And to give you an idea who's playing in the space, it's the people like Hitachi or LG or the manufacturers of these big bits of gear that you might either put in a factory, in a warehouse, or you might put into your home, washing machines and things like that. So AllJoyn is going to that, and its whole goal is to deal with this. How do I deal with this heterogeneous environment where I need to be able to identify services out there, I need to be able to securely connect to them, and I need to be able to transact data between them. And that's very much what AllJoyn's about. And as I said, that's absolutely gone into Windows on my desktop, all the way down to Windows IoT Core. So really fascinating to see what's going on in the industry. And if this kind of space interests you, go out and check out the All-Seen Alliance, because the AllJoyn is part of the All-Seen Alliance. Scroll all the way down to the bottom and look at the partners. It's a huge list of kind of names that you will know, and these people are all part of that process of how do you solve these kind of interoperability and cross-platform security issues. Okay, kind of going back to what Lee was talking about before. If you think about, there's kind of 4 areas. So I kind of touched on devices, and I said there's a whole stack of devices out there, which frankly, at the moment, with the current technology and the price point that people want, really won't be capable of doing too much security. If you think about your Fitbit, I'm sure I'm not the only one wearing my Fitbit. I have no idea how it communicates, but I've got a funny feeling it's not doing too much communication, encryption, but it's talking to my phone. And frankly, it's a low value asset, a number of steps. If you really want to know it and hack it, you're more than welcome. But it's then talking to my phone, and then obviously I'm hoping that from my phone, which is more capable of doing a secure transaction, it's then going up into their cloud service. So that's a good example there of a gateway, a kind of an action. So I'm going to talk about transports, gateways, and services, and pretty much in one slide, because I think it is. So we've got a number of classes of styles of devices. So I've already touched upon the kind of the IoT core devices. There's the Intel Edison devices. There's some embed devices, the BeagleBone greens and black devices. Those type of devices are pretty capable, and they're capable of doing encryption. So those style devices we see absolutely connecting directly from their source of data, their sensing, or what are their actuators, all those types of things that connected onto them, and can directly connect up into the cloud. So one of the things in the middle of this is something called IoT Hub, which I'm going to talk about more in a moment. So we've got different styles of devices. We've got devices which can talk directly. We've got devices which might go through some sort of gateway. And it might be a local field gateway. And I would say a Fitbit and talking to my phone would be a great example of a local field gateway. But maybe it's a factory. And maybe I've been building these IoT devices for the last 40 years, and I've got some weird and wacky protocols in there, and there's no way that I'm going to expose those directly out onto the internet and up into the cloud, because it's just not capable of doing security. So that's where we have this thing called a field gateway. And it can be talking whatever wacky protocol that might have been around for the last 40 years, and then you can do protocol translation. And I guess, certainly in terms of what we talk around Azure, I guess probably the primary protocols that we typically transfer across into is the AMQP, so Advanced Message Protocol, Advanced Message Queue Protocol, which is absolutely an Oasis open standard. It's what we've implemented onto Azure, into IoT Hub. You'll find it in Amazon and all those kind of things out there. So very much a standard out there. But we support a whole range of different protocols that are out there in production today, all the way down to, which I believe is a very popular one, is things like the OPC, which was used a lot in enterprise-based solutions in the last 20 years. But things like MQTT, which again is a protocol that's been out there forever, an IBM protocol which has probably been out there for the last 20 or 30 years. Being able to bridge those types of devices, which might be talking locally MQTT, but maybe they can't do TLS security or SSL security. So be able to bridge those types of things, and all the way down to the kind of thing I just mentioned around ORJoin and CoAP and these types of protocols which have been out there for really constrained devices. And another scenario here, we've kind of got a hosted gateway. So these ones are here are typically where the device can't do local-based security. So you don't want it to be passing unencrypted data across the internet. In a case where the device may be able to do secure protocols, maybe it's a protocol that we don't support, you can go out there and put a hosted server-side gateway, and that's kind of more for the scenario where the traffic going across the internet is fundamentally encrypted, or maybe it's really low value and maybe you don't 100% care about if someone intercepts it. But those are the kind of ideas where you can actually go host a gateway, so maybe you don't want the overhead of putting in a gateway into a factory, for example, or things like that. So you can go and put these gateways out here. So in the middle of this diagram here, we've got something called IoT Hub, and in fact, I think we just announced it today.
GA was today.
So GA was today, so it's been up in preview for a while. And its goal is to be an internet scale ingestion engine, as well as be able to support things like command and control. So I think you can see down there, you have multiple hubs. The idea there is it scales up to around about 10 million units. And then obviously you can go and have multiple of those units out there. But it is intended for mass ingestion of data. And we are working with a number of vendors out there who are building things like car systems, things like that, and taking that data that's coming off the instrumentation out of cars and engines, all that type of things, and being able to stream it up there for doing things like predictive maintenance around those kind of things. So at the heart of that is an identity. I think we had an identity, and fundamentally the identity systems are kind of pretty much the same. You have sort of a key that you're happy to kind of give out, proper key, and we deal with creating what's called a SAS, a secure access signature token, and those are the things that you're not sharing critical tokens across the internet. So all devices out there have an identity, which means that if you've found that you figure that you've got a rogue device out there, you can nip it in the bud centrally and say, look, I'm going to disable you in the central hub, and that device can no longer participate as part of that. As I said before, we support things like command and control, so maybe you want to send down a critical message down to a valve. Maybe it's a water system, maybe it's a watering, I don't know, Sydney water system, whatever, and you've got a SCADA system out there and you want to be able to send a message to shut down a valve. That's the type of thing we want to be able to do that and securely. We've obviously got things like device management, provisioning, all those types of tools out there. And we support pretty much the industry standard protocols that have been out there for some time. So as I mentioned before, we have AMQPS, so it's basically AMQP over SSL or TLS. Today we announced, which is awesome, we announced MQTT support, native MQTT support As I said, it's been around there forever, and a lot of people who've got existing solutions out there want to be able to do these transactions. Again, it'll be over secure transport. You can expect to do that over TLS or SSL. I suspect TLS. And you can also post messages there over HTTPS. So pretty much any device you can craft up an HTTPS request or post request can post up a message up into the system here. And as I said, that kind of gets up into the system, and then once you're in the system, then you kind of get the data into machine learning and stream analytics and Hadoop and all those types of wonderful things if you want to go and do some big data analysis and the things that are going on there. All those kind of services are sitting behind in Azure, can now get kind of access to that kind of data. Kind of going back to the open source bit again, I mentioned before, in fact, down on this slide over here, down the bottom left-hand corner, I talk about these are a range of devices out there which maybe are capable of doing secure transactions up into IoT Hub, but maybe need additional work. Maybe there are AMQP libraries out there, MQTT libraries, things like that. So to that end, we have actually, as part of the Azure IoT SDK, which I said is all open sourced out there, put out a whole stack of agents. And again, they're out there for Embed, they're out there for Linux, they're out there for RTOS systems. All these libraries out there exist today. So if you want to go and build a solution across pretty much any of these platforms or prototype solutions, and you're worried about security, we provide all the SDKs for you to actually start building out your solutions on top of them. And I think, Lee, that's pretty much where you're going to click.
Yeah, and I'm conscious of time as well. So, thank you, Dave. So the purpose of this slide and kind of what we wanted to present as a story is that a lot of what Dave's talking about, a lot of what we deal with day to day, thinking about the complexity of IoT solutions. There's a million moving parts. There is the devices, the network, the protocol, the gateway, the transport, all the moving bits and pieces. And these are very technical challenges in our world. We understand that, we deal with that. When you go and look at a solution like IoT, it's typically targeted towards a business outcome. It's typically going to drive optimization in logistics, it's going to drive cost reduction in some process, or it's going to look around transformation of some way in which you engage with customers or engage with your business. And all of us work for somebody that has customers, logistics, a channel, and process to work around. The reason why we created the IoT suite, which is really the pulling together of the moving parts. So as Dave touched on, Hadoop, IoT Hub, there's web jobs, there's stream analytics, there's real-time processing, there's document DB for storage. There's a whole bunch of moving parts inside of that. Azure IoT Suite is really a way for you to kind of go and simply switch on a solution. And I've got a bunch of slides, but we're not going to get time to get to them, but it kind of demonstrates the simplicity of saying, what is it you want to do? Do you want to monitor some things? Do you want to predict when things are going to break? Do you want to control and maintain certain assets? Then you go to the AzureIoTSuite.com, you choose one of those workflows that you're trying to solve, and it will go and create for you. So you still need, you need the Azure subscription to do that, but you can do it in a free trial. But it'll go and create the moving parts underneath that. It won't require you to go and figure out, well, how much document DB storage do I need? How many VPN tunnels do I need to create between the edge and the website? And how do I configure Power BI? It'll do all that for you. It'll create it all for you. In fact, it sets it up with a sort of 5 or 6 synthetic devices generating transactions, so you can see data flowing in, and then you go simply in and you can actually add in your own devices. And as Dave mentioned, the SAS keys, you can create your secure access tokens to connect those keys in. But it's designed to productize what is, we know, to be a very complex technical problem, but to productize it in a way that business owners and operations people can look at it and go, yeah, okay, I see what it's doing, it's solving my problem. So it's kind of simplifying that process. And you can go try that for free, AzureIoTSuite.com, run up an Azure trial, you can get that and play around with that for 30 days and just kind of get a sense of what an IoT end-to-end solution looks like. So you get Power BI dashboards, you get inbound ingestion of events through IoT Hub, you get the web jobs, you get all the storage, all the pieces you need in that, and you can play around with it, as I said, for free, just to get a sense of what that looks like and what it means to the business. So it helps accelerate that process of getting the business on board, but at the same time, to all the points Dave was talking about, it means the business isn't going to go out and start pulling together some bits and pieces of technology they've seen that solves a problem without a consideration for cost, security, risk, and process. They're going to get all those pieces because it's built into the platform that they're kind of pulling into. you know these slides say confidential until
Yeah.
clearly it's not. But they were at one point in their life. So we just want to leave you with a kind of just to walk through a process that we generated. So I don't know if you guys know, but it would have been about 2003, I think, around the time of Windows Server 2003, that we realized that, holy shit, security is quite important. We should probably think about putting that in our products, stop living open ports, creating websites that just fire up and do everything. So Microsoft went through a process called the Secure Development Lifecycle. We ripped our engineering team apart, and we reset and we rethought about how to build products. Hopefully we got it right. I don't want to show of hands because I really don't need the aim. So we built this SDL process, and inside of the Secure Development Lifecycle, we adopted a mechanism and a model called STRIDE, which is about understanding where and how to best apply security to a solution or a design or a product you're building. Look, sucking eggs, I'm teaching you just some very simple stuff. But one of the challenging things with IoT is actually draw that architecture out and think about what the architecture looks like. You know, most of us are very familiar with drawing up a three-tier database platform with a database, middleware, and a website front end. It's pretty straightforward. We get it all. We understand the moving parts. When we get to an IoT solution, there are significantly enhanced levels of complexity around even just the devices themselves, and then all the way through that channel. So it really helps to draw up that application, then kind of break it apart and figure out the architecture, figure out what's being transmitted, what are you doing, what's the cost of the piece, what's the impact of the business if it was exposed, and walk through all those processes. And then you take the STRIDE mnemonic and approach it to each, or apply it, to each element of that diagram to just determine the risk and choose, do we mitigate or do we not? Do we work around it or do we live with it or do we have to fix it or do we remove it? So STRIDE essentially stands for S, spoofing identity. Can I actually pretend to be, can I do man in the middle, can I pretend to be this device and therefore encapsulate the data it's transmitting and pretend to be one and then pull data either out of the mothership or from the device itself? Is the device potential for tampering? If the device sits in a locked secure cabinet at the bottom of a 64-floor building and there's no way to get into it without a second set of keys and you need Dave's fingerprint to get in there, clearly tampering is not a challenge from a physical perspective, but maybe it is from a software perspective. Repudiation, you can read these things. Information disclosure, what does the data tell me? What does the information actually mean if someone got it? Is it PII? Is it not PII? Is it metadata or is it associative data that we can pull together? Denial of service, elevation of privilege. You can see it. In fact, if you go, do a quick search, not RSA Monkeys Lee Hicken, but go search for Microsoft STRIDE. There's a whole set of content around applying this mechanism, this process, to your analysis of the solution you're trying to build. And we're not saying it's the best solution, we're saying it's the solution, the model we used, and it's a model you can adapt and use within your own businesses, but it's a starting point to think about what do I need to do, what do I not need to do, and how do I essentially, think about why we're doing IoT. IoT is not an exercise in playing with shit. IoT is an exercise in actually delivering an outcome for our business, or for our customers, or for our supply chain. So think about what we're trying to do at the end of it and figure out where the real risks are and where we need to invest that time and effort. And this is the mechanism for which you can use to apply that. With that, we're 10 minutes over,
Yep.
probably.
No, that's fine.
But I'll leave it at that. We're happy to take questions, as long as they're not questions about why Microsoft is getting into the security game.
Any quick questions for the Microsoft boys?
Can we get a set of slides?
Yep.
So I'm going to, at the end of it, we'll do a blog and slides from today and also from the Melbourne one. I'll distribute them down so you can all level it.
Yeah, they'll be up on my SlideShare as well. Just go and search for Dave Glover.
So given that so much time and effort and frankly money has gone into developing an approach that is multi-layered, where does the human factor come into it from your perspective around legislation? So for example in the UK where it was proposed that legal backdoors be placed into software and hardware development, and obviously that presents that's directly counterintuitive. So I guess that would be against the tampering option, the tampering option and the spoofing option. So I guess what are your thoughts on when you do have such interplay amongst hardware and you have a concept of metadata and big data? What's your thoughts and response on who carries the risk or the burden of breaking in?
Oh, right. I'm not sure I can give you it's a great question. And I have to say, I'm dancing. And he's sitting down.
I have an answer, but I'll let you answer.
Okay, no, you go.
No, I want to hear the answer.
Okay, that was the wrong answer.
To be fair, I'm not necessarily sure that there is any particular answer.
Yeah.
Given that so much effort has gone into doing precisely the opposite.
Yeah, and I'm not in a position to stand out and say something official on the Microsoft, because there are some official lines that are sitting up there about how we do interact with government and worldwide. And clearly we do need to interact with government. And but you've noticed also in the press that we've been very firm about pushing back with requests for data access, things like that. That's kind of our position. I'm not sure I could really add too much more to that.
Look, there's two sides to it, which is Dave's spot on, which is we have a responsibility as both local company here in Australia, as a global company, to adhere to laws. We're never going to break a law. That's not our business to be in the game of breaking laws. But at the same time, as Dave said, our first set of responses is always to push back, define reason, rights, and access. And before we do anything, we will always make sure the customer is very visibly aware of what is being asked of them. But it's such a broad conversation. There's actually we should share it. I'll make sure I send it to you in the notes, Andrew. We have a website that very few people know about. That is, I don't know why, but because we don't advertise it very well. Where you can actually go in and we do it every 6 months. We write a report on all of the access requests we've had, what we did about it, how we responded, and whether they went to litigation or not. And we basically share that information. We don't share your names, we did it, obviously. And the numbers are big, but actually interesting. You know what our biggest area of investigation is? Skype. Skype is huge for records of that and data of who connected what and whatever. That's where we get most of the requests for data from. But you can go look at that data and see what we're actually doing, what we're not doing. We expose as much as we can, but it's thank you, but it's a very, very tricky subject to kind of give a definitive answer to.
That's okay, I'm fine with that.
Go for it.
You go
I have
then.
a very simple technical question.
Oh,
What's
that's
the
true.
relationship between the Windows 10 desktop and Windows 10 IoT? Like, is it a subset, or are they completely different code bases?
So the question was, what's the difference between Windows 10 desktop
Yeah.
and Windows IoT? Very little, actually. So Windows IoT Core does not have a desktop UI. So you can run applications in kiosk mode. So there is a different experience there from the user. But from a kernel perspective, from an API perspective, they are the same. They all run the universal core. I'm not sure, it's called WinMin actually. So they run the same core that you'd find all the way up to our servers. And they run the same API. So they run this thing called the Universal Windows Platform, which is the way in which we build modern apps today for Windows. So it is the same. It's not kind of this sort of similar. It is the same. In fact, I have picked up applications on my desktop and it's a code, and I've pushed them and recompiled them for ARM and run them on my Raspberry Pi, and they just work. And it's
You
awesome.
answered that. I would have said market.
And it's great. And I'm gobsmacked.
Was there one final question for Alan? I was asked Vince to pop down while we're having.
No, exactly what she said. I was going to ask you the same kernel.
It is the same.
Thank you, everybody. Sorry, one last question.
We know that security doesn't come for free. There is always a cost to it. So when we are talking about devices, small devices, when we are connecting with the cloud, they need to authenticate, right? As per the API, we need to authenticate. Now when we are authenticating, we are consuming the power for that. Now devices has a limited power, right? So have you done any analysis, or if you have any data where you know that if we are using more secure, what kind of extra power, because power is limited there, right,
Yeah.
for the devices.
Yeah, it kind of comes back to the point before I talked about, I think it's where I started, there are a couple of classes of devices, some which just today aren't capable of doing that. I'm also quite active in the maker community, and I do some work with some very small devices, and there's been some real strides in security on those devices. You had to do kind of HTTPS over some of these very small devices. You might know them as Node MCUs and ESP8266s and stuff like that. Very small devices. I would say the landscape's going to change quite radically in the next 2 to 3 years. And we'll have devices out there, small devices, which are actually really capable. Look at the new devices, new CPUs are going into Arduinos and things like that. They're actually getting to be pretty capable. But it'll take a while for that ecosystem to catch up. But fundamentally, there are going to be some devices which are just never going to be able to do it, and the price point will dictate that for the next 5 5 years. I want to say 10 years. Next 5 years.
Great.
Thank you.
Perhaps we should.
Yeah. Thanks, guys. We're just going to get Vince to come down from Kavata. He's our door passport sponsor. Just going to have a quick word. Vince?
It's actually going to be Rob.
Okay, Rob, even better. For those of you who haven't put your name in the pot in the back yet, please do before the end of Q&A, and we'll have a chance to draw some nice prizes.
That's a shame.
So I guess it's a little hard act to follow coming on from, first of all, Salesforce, then Microsoft. So my name is Robert Bartlett. I'm from a small startup here in Sydney called Kavata. We are an applied security company. So we've been around for a few years. We launched on the ASX, when was it, like late 2014. So in all this talk of IoT, there's sort of one thing that I think, there's a number of things that are consistent between the talks, but ultimately at the end of the day, there's data involved somewhere. And that data is coming from a device, it needs to go somewhere. And transport level security, that's something that's relatively well known, well done. TLS where it's appropriate. Now, Kavata, I guess, looks at data itself and looks at saying, the approach we take is, how is it that we can protect this data through its entire life cycle, whether it's coming from an IoT or IoE-enabled device, whether it's coming from anything else, and being able to provide the security around that data to say, whether it's in one location, whether it's data that has been collated, whether it's being disseminated, rules around how you combine the notion of identity, so how that data, who has access to what, access policies on that data, so whether it's something that's geo-related, whether it's something which is time sensitive, any other sort of access criteria, that all sort of fits in there. And then thirdly, around key management to say, okay, I want to protect my data. What is it that is really important is how you actually encrypt it. So Kavata is a name which hopefully we'll be hearing more of as time progresses. So as I said, we're currently small. Worldwide, we're about 50 employees. All of our engineering is currently here in Sydney, so homegrown. And we're actually in the process of opening a brand new office this month in San Francisco to coincide with the RSA conference. So,
thanks. Cheers. Thanks, guys. We'll take a 5-minute break, get a drink, and we'll pizza left around that, and then we'll start with the Q&A. Okay, ladies and gents, we'll start now. I'm just going to introduce our 3 panellists. And what I'll do is I'll get them to describe a bit about who they are, what they do, where they come from, give you their short story, and then we'll go to Q&A. So, first of all, we've got Craig Hall.
Hi, my name's Craig. I'm a defense analyst with FireEye. I'm not here to tell you about any solutions at all to do with Internet of Things security. I'm here because I'm an incident responder. I'm a network defender. I've got a lot of experience working against state-sponsored attackers who are currently utilizing IoT devices in their attacks. So, thank you.
Clarence from Oracle.
Hi everyone, Clarence Chair from Oracle. My prior role was the head of identity and access management pre-sales for Oracle in Asia Pacific. But for some reason, my boss thought that I could take up IoT, digital mobility, and other bits and pieces. So I now have a bigger portfolio, including identity and access management. I think this is a really interesting topic, still maturing a lot. In fact, I'd be interested in some of the comments and questions tonight, and where we go from here.
And we're Daniel from Dropbox.
Cool, yes, I'm Daniel Lewison. I lead the solution architecture team at Dropbox here in Australia. And we're not IoT related, obviously, but we certainly have our fair share of cloud security conversations with customers. So, yeah, happy to take any questions.
Okay, great. So the whole idea of this session is really interactive. I'm going to ask a few Q&A. The hope is that I don't have to do anything for the rest of the evening, and you guys can just I'll ask away. So before we start, is there anything you want to throw at the panel? Or?
Andrew, I have a question. Can
Yes.
we please ask the panellists to have a microphone so that we can hear them? Is that
Yep.
okay?
You know, hear the back?
We do have one, I believe.
We do.
I don't know, it's a bit, yeah.
Jamie, do you want to say on the mic quickly?
Yeah, it's on, is it? No.
The words come up on the screen and there'll be a tune you know.
Okay, all right. Just need to lean down. Oh, for sure.
Is that device secure?
It's going to be. Hello there, is that all right?
Doesn't matter, it's low value data.
I haven't even started.
First question, does that device have an IP address?
I suspect no. What do you think?
I would go with that.
Okay, so we've also a description about the guys, so we'll start. So the first question I've got, I won't ask this one to you, but has there been observed uses of IoT devices as part of APT campaign or targeted attacks?
This is probably aimed at me, and I've been cleared to talk about two things to do with threat actors using IoT devices as part of state-sponsored campaigns. I've worked on incident response for some very, very large and sensitive organisations where we've observed network printers being utilised by threat actors for data staging and exfiltration. If you put a device on your network that's internet accessible and it has a 100 gig hard drive, the threat actor is going to use it, and we've observed that across a couple of different threat groups, both state-sponsored. No guesses, no prizes if you guess which state it is.
Clarence, do you want to talk about that?
I'll just add to that. I want to approach it from a slightly different angle, because I think when you look at IoT, right, we've had connected computers, and then the connected computers that connected to networks, and with the internet, and then mobile devices, etc. We've seen a myriad and a varying different threats and different attacks over the time. When we had internet, SQL injection, denial of service, DNS poisoning, etc. My feel is with IoT, we haven't even seen the different. There'll be new patterns of attack that's going to come up. There'll be new types of threats that. There we go. All right. There'll be new types of threats that will be coming out that I think we shouldn't take for granted what we've learned in the past to predict what to see. I think we need to be a bit more open to the different type of models and attacks. Right.
Okay, good. Daniel, do you want to have a crack at that?
Nothing to add.
No, good. Okay. So I'll give a bit more general one. Yeah, is the industry doing enough to keep pace with threats of IoT, particularly threats of cloud issues as well?
Yeah, look, I mean, in terms of cloud in general, I think, the the industry is doing its part. I think it's still maturing within the enterprises. I think there's definitely some catch up in terms of, like we've seen BYOD, BYOA, and those kinds of things, but actually adding enough governance and control around these kinds of initiatives, I think we're still playing a little bit of catch up there. We're certainly seeing that in terms of our customers and the kind of education and discovery we're doing with them.
Yeah. I think there was a question before around, with IoT devices. I mean, Moore's laws have, kind of spoiled us to have, more powerful machines and doing more and faster processors, etc. But I think with IoT, a lot of the constraints are actually not. We can't actually physically overcome them. So there's going to be a lot of devices that are smaller, less processing. There's a lot of constraints on these things. So I think what I've seen is there's a lot of work happening around some of these constrained environments. So standards bodies and people coming together. It's still early days, but I think it has to happen. And I think there was a lot of talks around authentication, linking to identity, transport level security, etc. Today, one of the next barriers we need to crack is around things like authorization. Right, a lot of work happening again around there. I'm authenticated. I'm a device. I know who you are, but what can I do? Who can it do? Who can do things to you, and what can you tell things to other people? So I think that's the next frontier. I think we need to crack around the authorization level.
I'm thinking about it in terms of attack surface. The exponential growth we're seeing in IoT devices, in BYO devices, is opening up so many more attack surfaces that are being targeted by attackers, by script kiddies, by financially motivated threat groups and state-sponsored threat groups. It's going to be great job security for me in the network defender space, and it's going to be a huge challenge for the engineering guys to secure it.
Good. Any questions?
Do you have any experience with digital forensics and IoT that you would like to share with us?
Sure, I'll just say that out to the crowd. Do you have any experience with digital forensics around IoT? Is that right?
Yeah, because that's the other side of the attack, right? And security, like the investigation afterwards, I suppose.
One of the devices just run off SD cards, USB storage.
I'm always cautious with how much I can tell people about the digital forensic work that I do in my role, and especially seeing as we're being streamed on the internet. So I'm going to not go into any specifics on that, and I'm going to say that from a defender's point of view, the great way we detect utilization of IoT is through network security. Command and control traffic looks the same regardless of what endpoint it's hitting. Data exfiltration looks the same regardless of where it's originating from.
Yeah. Anything?
Anything else?
Thank you.
Good. One of the big questions that's always around security is how do we secure things down but enable the business, and how do we do that cost effectively? So I think, especially from a cloud point of view, if you want to nail everything down, can you actually do business? So how would you do that in your environment?
Yeah, sure. I think you can, and obviously our perspective is that you can utilize, cloud solutions and also consumer selected solutions, to improve, agility and things like that within your business. And I think if you're mature enough, you can actually do it properly. You can put the right kind of governance and control in place, and you really need to look at IT not just being finishing at the perimeter of your company, but obviously including the cloud as well, right? So what we work with customers on and advise them to do is look at, when you look at data loss prevention, digital rights management, whatever it might be, obviously consider cloud really as part of that environment, right? So I think, you can't really ignore it from an apps perspective and things like that, but I think you can embrace it and actually, deploy these kinds of things securely. In fact, I think you've got a security advantage by utilizing the cloud, right? Because you're kind of transferring a lot of the risk onto the vendors, which obviously has a different level of scale that they can bring to bear to solve those problems, right? So obviously, I think it's more secure than trying to do it yourself.
Yeah, I concur, but I'm going to draw that back to IoT a little bit. I actually don't want to take credit for this comment, but I was talking to my colleague Darren over there, just over recently, and one of the things that I think, as security experts, there's a lot of different threats and different levels of protection, etc., that we expect from solutions, devices, etc. But wouldn't it be great if we had IoT devices that follow some sort of generally acceptable, understood rating? So you go out and buy. You go into the beach, you go out and buy sun protection, you know that you're going to get a UV 15 plus, 30 plus, 50 plus, or whatever it is. Until we can get to some sort of security rating that this device can actually provide you, and what sort of that level of ease of understanding, I think there's still a long way to go on how we can get these things secured out there. So if I'm securing critical patient monitoring data, for example, you want something like UV 50 plus, right? If I've got sensors distributed on my farm across acres and acres, like tens of thousands of them, you may not need that level of security. So I think we need to get to that level of thinking, and as an industry, have those kind of levels defined. And then a lot of things, following off that becomes a lot easier.
Who's going to drive that? Is that going to be one of the consortiums, or do you think it's going to be just the business as a whole?
Yeah, I like to say Oracle, but what's Microsoft? We can partner together, I think. It is a big problem, but I think with the different assessment ratings, so we're maturing to that point.
Mm-hmm.
But this is a problem that we have to face, and Internet of Things, connected things, is not something that we're anticipating. It is happening. It will happen.
Can I just add to that? I think it'll be a standards body, and I think that the IETF, because it is that engineering level type stuff, has a great role to play in that. We can't have an Oracle, trust me, it's 50 plus. We should be, or a Microsoft 50 plus. We end up with, 50 is different everywhere, and then we're asking ourselves, what's 50?
Yeah.
So we need an independent body that looks at it objectively and then drives the understanding out into the community.
So, sorry,
there is a body called Internet of Consulting.
Yeah.
They are looking about the protocols and all, and they are looking at security. They are independent body. They are not like from any specific group.
Yeah, and that's one of the challenges though we have is that's security from a manufacturing point of view.
Yeah.
Not security to the consumer's point of
and
view.
then everyone
Yeah.
has to it.
But I'll give a very quick example. So from an identity perspective, right, if I look at the US government, for example, there's a NIST framework around identity assurance levels. So from identity proofing, if you provide X level of documentation or verification information about yourself, you've cleared, level 1 of identity assurance, level 2, etc. And that identity proofing process is, it's still a long way to go, but at least it's a good step in terms of how you define those types of, levels of clearance.
Dave, have you done that from a cloud point of view? Because obviously that's you're a bit more mature in the process.
Yeah, obviously it's a bit more easier if you're a product, right? Because you just need to sort out the transport, the encryption and transit and the rest, and also obviously the authentication thing. So I think it's definitely easier being a product, but I'll definitely echo with the Oracle guys. I think the future will be one where there will be some security standards around IoT, and I'm definitely worried, like the Microsoft guys as well, that there's definitely different classes of IoT devices at the moment that has different kinds of capabilities around security, and some obviously have barely none, right? So certainly as a consumer, that's something I'm worried about, but obviously it doesn't relate to our product or anything like that.
The IEEE are currently trying to drive standards in the electronics manufacturing industries to ensure security, and they've got a pretty good reputation. They're also working with ISO to try to get international standards in place, and it's very much a case we need to get more conferences between the electronics industries and the information systems industries working together.
I'm going to raise a very controversial opinion, and you all might hate me because of it, but I've done so many incident responses to compliant organisations, that have met every standard, and I don't believe anything will ever be secure. I approach every day that I turn up at work as, where am I finding the attackers today? Not where's a vulnerability going to be, or is that device secure? I treat everything as already compromised, because they are going to be compromised at some point. Given enough resources, if someone wants to compromise you or a device or an appliance or whatever, they will. And this is where the whole argument of defense in depth comes in. You need to make your appliances and devices robust and defendable, not secure.
How do you keep up with the rate of change? Obviously things are changing so fast. How do you manage that?
How do I manage that?
Or as a security industry, as a general?
I mean, I can't speak for the whole industry, I can speak for myself. I have one client come to me with a compromise, we fix it, we take that knowledge and we leverage it across all of our customer base. Essentially, it's R&D in production. Like I said earlier, I don't have any solutions, I just have a network responder's point of view.
Yeah, I mean, this is the interim, and I work in security myself, and we know everything's open. It's just a level. But the thing is that how do you actually communicate this out to the customers? And how do they then make choices? Like we talked about the SPF, the sun doesn't change, people don't change. How would you go about that communication?
Yeah, I think from our perspective, I mean, I agree with Craig as well. I mean, we're always under attack, that's the reality. And you can prevent as much as you possibly can and embed security throughout the life cycle of your product, but it's really about the detection and response. And I think the only thing you can do with consumers is, and whoever your customers might be, is to communicate quite transparently, right? So like the Microsoft guys around privacy, I think, you take the same approach, with security as well, around, notifying customers if there are any, vulnerability, or if there's been any issues and things like that. I still do believe, though, that, certifications and credentials do play an important role, because it kind of sets the bar. Right, so I think the SOC certifications and ISO certifications are there for a reason, but I think everybody definitely has always constant work to do around security, despite however many certifications you might have. So I hope that answers your question.
Do you think that there's an aspect of, I guess the differential in what I'm hearing is the difference between compliance and communicate to versus educate and enable? So one of the challenges you have is because there is such a rapid rate of change in mass, I'm going to use the term mass media, sorry, perception, security is really complicated, the lay person can't understand it, which is absolute bollocks, they can. But they can. It's not difficult. You've done it here this entire evening, and while I would like to think the average applicant in the room is quite reasonable, it's not difficult to explain to somebody, don't give your password to someone. But there's a difference between, do you feel that there's a difference in the way that, I guess, from a product perspective, that you can enable someone and educate them versus simply communicate at and to?
Yeah, I think you're exactly right. I think we do try and educate. I think a lot of vendors try and educate. And I think it's important. Our biggest issue from a security perspective, despite what you might think firstly, is actually that people reuse passwords. Right, that's the biggest issue we've got, is that people use the same password for their Dropbox that they use for their LinkedIn or Gmail or whatever it might be, and if one system becomes compromised, then the other one becomes two. And the two factors are only one click away, but nobody turns it on, right? And I think everybody kind of has that challenge. The user is always the weakest link, you know, so education is super important, for sure.
Yeah, I think education, enablement and all that, but the challenge I see is a lot of organizations well, let's put it this way, a good enough security or a false sense of security, that is very, very common. I've got some security controls in place, that's good enough, who's going to hack me? There's a bit of a fault, like let's put an IoT example, Bluetooth for example, right? I pair it with a device, right? You'd think that that device and the connected device is going to be the one that's communicating through a channel. Have you guys ever bought a Bluetooth sniffer and see what it can do?
Yeah.
It's amazing how much data passes through Bluetooth devices unencrypted that you can very quickly, decipher what's going on. So I mean, there's a bit of a false sense of security, and I think that's been, as you said, I'm compliant with different standards. I'm not vulnerable to attacks, but hey, at the end of the day, that's why FireEye has a strong presence in the market. So I think that's my point. I think it's yeah.
I'd just like to point out that the Australian Signals Directorate, ASD, their big four for preventing cyber attack are really simple. And the number of organisations who can't even get the simple things right, as opposed to the complex bits, is still very high.
Some of the big four out of interest.
The big four, things like application whitelisting, vulnerability management, a lot of basic IT kind of concepts that aren't heavy security ideologies that need to be done in order to secure your network. They're not fancy devices or appliances that you buy and plug in. It's just getting your IT department to know the basics. Got a question?
With the invention of driverless cars, what's being done for security to stop people hacking into those things and just steer them off the road and then driving along with their family? Do you know about that? Yeah, so I heard a story that someone actually hacked into the user interface of the radio and was able to take control of the vehicle. Is there much being done for security and making that become a reality?
I don't have any sort of official answer for that. I can only offer a personal anecdote that I hacked my own car's ECU to give it 30% more power. Because Volkswagen
and lie about its emissions.
You just voided your warranty.
That was already done.
Well, I did. Every time I took it back to Volkswagen, they kept reflashing the ECU and putting it back to standard power levels.
Can I talk to you after this?
Sure.
Well, I'm going to say, just based on what I've been observing in terms of news and things you hear in the market, a lot needs to be done. I don't know how much has been done, but a lot still needs to be done. But I actually think with things like self-driving cars and all that, the implications, obviously, if there's a malicious intent to harm someone, to remote control and kill a person, obviously it's going to be a huge threat to society. But I think in terms of how that's going to change things like insurance models and the algorithm on how you control cars and physical safety, how to respond in different situations. I mean, that logic, I'd like to do an assessment of how you make decisions when, I've got three choices, either to run into a pole, kill a cat, or run someone over, right? What choice do I make? And that, I think, is actually more fundamental down to the hacking. I think they need to figure out.
Well, that choice is down with the lawyers, though, not necessarily the IT guys.
Yeah, no, I just hope they fix it,
Yeah.
Oh, sorry. On this point, maybe I can invite you guys about the cars. There is, I forgot which hacker conference it was, but it was last year. There is a team of guys who have been hacking the Tesla car.
Right.
Okay, so you do some keywords on Google, you will find it. It's very enlightening how they have been able to hack into the Tesla car. the thing is to be able to get into the car, because they're pretty sophisticated car, they're not newbies. They had to actually dismantle the electronic and get through the connectors, and it's just go through that. It's really delightful. I mean, you would enjoy it to how they've been able to break into it.
On the other hand, I think last year or two there was a team of couple of guys who hacked into the friend's car and managed to take over completely without any access to it. Not a Tesla, it wasn't a Tesla.
This one is a Tesla. Two guys, I mean, the guys say, okay, take my Tesla, I trust you guys, don't break it. They just couldn't get into it, but as soon as they got, the dashboard out and look at the plugs and they would tell you the strategy they use.
So there's another story, not a Tesla car. They managed to access the car. At first, the first round they had to actually have physical access. At second round, they actually managed to take control of some Jeep or something like this.
Yeah, but that's pretty late.
Actually, they took it to Jeep, as far as I know, they are trying to progress. I'm not sure exactly where it stands, but there is some. The response was that the industry is becoming aware of the situation and trying to address it with the standard.
Don't worry about it.
The guy's name is Charlie Miller, and then there's the other guy whose name we can never remember. Yes, Charlie Miller and the other guys.
As a former Jeep owner, I'm just most impressed that they managed to get it running long enough without breaking down.
So we're trying to fix it.
I've got a probably weird question, which I'll apologise for ahead of statement. But the longest stuff, I always ask the why question. Like why the bloody hell do we need it anyway? Right? And from a driverless car standpoint, whatever things, you talk about the insurance and those peripheral services to protect and secure and safeguard these kind of things, the Internet of Everything as opposed to the Internet of Things. And I always ask the question, why? Why does my fridge freezer need to have an IP? Why?
Maybe not the fridge, but the car, yes.
Yeah, I kind of become more familiar. And I go, there's a whole industry popping up, as a result of this choice. Everything created before. Let's go. Why are we doing this? We
Perhaps I can enlighten you.
Johnny.
Having your fridge having an IP address actually allows the manufacturer to make it a third cheaper because it doesn't need controls.
I love the fact that my coffee machine automatically reorders pods when I get to a certain threshold.
So from a support and maintenance standpoint, I get it. I mean, like all good software companies do run names, they love support and maintenance contracts, huge margins, that's wonderful. And when you look at it on a broader scale, I still have this itch I want to scratch of, do I really need to know that my
short answer is to make your life easy.
This is a salesman's. Salesman will tell you anything.
Yeah.
IoT for medical, IoT for cars, IoT for many other things.
Yeah.
Come on.
Get that.
That's a focus. Forget about the fridge.
Before the iPad was even invented.
Yeah.
Progress. I mean, some of these things won't happen. It won't turn out like being true and right and being sort of turning out in real business cases. But some of the things will. Maybe 1 in 10, maybe 9 in 10. Who knows?
Especially in medical sciences.
I get that. I get that whole medical device thing. I get that evolution. But in the
Clarence, do you want to?
Yeah, I can give a few use cases that I've seen so far. But before I do, if you've been following CES, the Consumer Electronics Show this year in Vegas, Samsung actually unveiled their latest fridge, which is IP connected, but you can actually take a photo of what's in the fridge. So when you're out shopping, you know what's missing in the fridge. So that's really cool.
Take a photo from inside the fridge.
Yeah, from inside the fridge. So you know what's in there and what's not, and what you need to buy.
That's gonna
Anyway, other better use of IoT. I think from my perspective, what I've seen, there's a lot around things like asset maintenance. That's probably asset maintenance monitoring. That's probably the more common one that we've seen. Sensors, looking at what's going on that and driving different events or analytics. Some of the more interesting use cases I've seen is around things like a different business model. For example, we've seen the IT industry, for example, has been disrupted around things like the cloud, so it's pay as you go. But there's also a lot of products and services now being consumed in terms of a pay as you go model. In terms of selling you a unit of X amount of dollars, we will allow you to pay for your consumption. I mean, I'm talking about things like photocopiers, tires, and things like that. So with these IoT sensors, we can actually very, well, I want to say accurately, I hope they are, understand what's the consumption model and charge the customer in that sense. So that's, I mean, healthcare monitoring and all that, certainly we've seen a lot about that, but some of the more interesting ones around a change of business model and how you can then differentiate from your competitor, that becomes quite interesting.
Insurance.
Insurance, looking at how you're driving your car and determining, what sort of premium that you're paying.
It disrupts everything.
Yeah.
Don't forget there's also the shiny factor. Look shiny.
Yeah, absolutely. Yeah. Because we can.
I want to break this topic back down to the fundamental basics of why we're all here tonight. We're here to talk about the Internet of Things and security basics around the range of it. A couple of the points are security doesn't go with Internet of Things. Fundamentally, from FireEye's perspective, right, you've got a massive attack surface. It's going to increase your risk and therefore increase your likelihood of some security compromise taking place. The next topic that's come up is to talk about who's responsible for education of people around what we should use it for. We talked about IEEE, we talked about IoT, apologies for whatever acronyms that we use. The people in this room are security professionals of this country. We are the ones that are responsible for talking to our employers and our organisations and our vendors about what's important from a security perspective. The other thing is to talk about, everything's about risk. No one's even mentioned the term risk tonight. We can have these appliances that are going to operate our fridges, that's awesome. But you wouldn't have one operate a cardiac machine. You wouldn't have one operate a dam. You wouldn't have one operate a Jeep, or whatever it may be. So by all means, let's introduce IoT things.
Okay, can I share my experience?
Absolutely.
I try to voice share my experience with Microsoft, because I have what Microsoft has presented here, I've been doing more than over a year ago into automotive in China. Okay, and the idea was to make sure that the idea was not to have just the car, but the subsystem of the car, IoT enabled. And the idea is because when you develop an electric car, because it's an electric car, it's not a fully baked thing. You have to modify it. And what I did is I was specialized into IoT devices long before that, before it was called IoT. But the idea was to ahead of time, because when you have an electric car or car, usually you have everything goes through the entertainment system. Okay, so that's a kind of a bottleneck. Go to that. That's what Tesla has got. But what I did is I convinced them, okay, leave that alone. Let's IoT enable every subsystem. So the battery pack, the control system, the power control system for the electric motors. Do an IoT device. Do like Microsoft VMI called what they call instrumentation bus. You do a peripheral instrumentation bus, because the bus inside the car, which is called OBD, is brain dead. If you want to enable some IP kind of traffic, wow, it's very, very heavy. So the idea was to say, okay, leave the what's called the network that is in the car as it is, but enable a parallel kind of instrumentation system based on IoT, and what I did is I choose the Texas Instruments CC3200, which I choose for tourism. It has Wi-Fi, and it has a crypto engine. And the full stack was in firmware, and HTTPS was in firmware. So you just, at the factory, just generate the certificate, you link up to the cloud. You can follow your complete. It's totally secure because you have to download software.
Until your certificate gets out.
You have to take the basic. No, totally system. It's an ongoing because there's no standard for it. But at least you use a crypto envelope, which you see during the factory process.
Cryptology is such a small part of security.
Come on, IoT is young, so you have to go by steps.
So don't put IoT into a car.
You do not have a big Intel chip there. What I had is $7 resource.
Yep.
What can you do with $7? I was very happy to have a supplier like Texas Instruments providing me a complete crypto API with all the software and firmware. and also capable of supporting 125 degrees, because in the car you need a high temperature. So go by step by step.
So let me just say about the cardio as an example, so that you know all the sophisticated medical operations today, plus putting devices into your bloodstream and releasing medicine while nanotechnology enabled devices are happening today. There's no point even arguing about IoT not being applied, because whether you want it or not, it's just happening. And the focus should be, okay, it's going to happen, how do we make it secure?
Okay. Do you know the Orange Book? This is a fundamental of security. If you don't know the hardware, you don't know the security. So, those security is in the silicon. If you know what has happened with, historically and all that, you have to bury deeper and deeper and deeper into the silicon, your root of trust. If you don't have root of trust, you don't have security. So start by the root of trust first. Put hygiene. Build up from there. That's what Microsoft is doing with the Azure, with all these kind of things. Nobody perceives it. But if you don't have a root of trust, you don't have security. After that, of course, you must not have any weak link. There's so many weak links that people don't see. I mean, you have some fundamentals. You have to build upon them until they have been those fundamentals are being flowed. At the moment, they're not flowed.
No, I think it comes back to the root point, right? So it is about what we think. I've got a background in process control, electronics engineering. I work in security now. We can't secure anything. There's no two ways about it.
But there's acceptable risk.
You take a risk. And I do that every day.
We've only just come up to a stage now where we can accept them for corporate use at the enterprise level as a risk. IoT is not the enterprise level.
Fundamentals, so they have to build fundamentals. But you need to know the fundamentals first. We don't talk about fundamentals today. We talk about certificates, we talk about anything, but we don't talk about the fundamentals.
Do you guys want to have a...
I was just going to make a... let's go back to risk for a second. So if there was a very, very simple equation for risk, right, it's the probability of something happening multiplied by the impact, right? IoT, the impact of IoT today is not that huge for, generally speaking, because the usage of it in most industries is not that high. The probability of something bad happening is high.
It's 100%.
Yeah, but the impact is not high because we're not doing much with it. But as soon as we start to, push more into the IoT boundaries and, starting to have businesses thinking of, delivering more, the risk is massive.
So maybe what we should do is accept that everything will get hacked and then just try and focus our security efforts on minimizing the impact.
So this is why the application of IoT.
Or you do as much as you can to reduce the probability.
Yeah. Well, that's prevention rather than...
So you say it's not integrated, right? So I said I was a process control engineer. How many people realise that the air conditioners, cooling systems controlling your server rooms actually have had IoT type technologies for 20 odd years, and I can get on the internet and they plug 3G cards in and I can find them and shut down entire data centers.
And the number of times those get hacked in penetration tests is nearly every time.
Yeah, and
Target in the US is a good example of that.
Sorry?
Target in the US where they got through to the main service through the air conditioning ducts.
That wasn't the air conditioning duct, and I can speak about that because this is one of the few customers I'm allowed to talk about, because Target talked about us first. It was a HVAC vendor. They had user credentials to VPN into the Target network, and they were compromised.
Admin password.
Yeah, and then they had poor password security. They got in. FireEye advised Target, you have attackers in your network. They took that alert and just put it to the side. And then 6 months later, we lost hundreds of thousands of credit card numbers.
There's been major organisations, manufacturers and all sorts of things around Sydney that have been hacked and engineers plugging in 3G cards and modems and they just get taken out, viruses going all over and all sorts of things.
And IoT devices are coming out with permanent 3G connections. It's $3 a month.
You just don't hear about it, it's hidden. And you guys know that, you can't talk about it.
I know that, I can't talk about it. This is why I firmly believe that the breach is inevitable. You cannot prevent an attacker from getting into the network. You can, however, decide how you respond to it, how you try and detect that attacker, and what you do after you've been compromised.
From that goes back to security is a shell game, and it's more a matter of how much effort you want to go in to protect, and then what the impact of that is going to be at the end of the day. and even if you are aware. So I mean, the reality is, how many attacks are going on right now that people are completely oblivious to? How much data do you know is actually being lost? And completely oblivious. Do you care? Possibly.
I have another personal anecdote. I was in a Southeast Asian country a few months ago where the client I was consulting to knew they were losing around $300,000 US every month. But the cost of fixing the problems that they had with their infrastructure far outweighed that, so they just accepted that as a loss.
Operating risk?
How long before that loss of the 8,000 turns into 3 million?
Problem for them. We told them the problem, we advised them, we put them in a position where they were able to make an informed decision, and their business management, people who are not IT professionals, were able to take our professional advice and decide for themselves what was best.
How many people in this room work in IT departments where on paper the attitude is we'll patch within 30 days of a patch, and you had to do the triple jump to go from one full version to another to the current version?
What are we talking about?
I wish I could say no.
How many times did that say this?
It's the people factor. As much as you can have good hygiene, all process procedures, social engineering is one thing, but honestly, absolute inertia in large-scale corporations is a really big challenge.
And then you find some developer who's got a Windows 2000 server sitting under his desk, and he's never patched it.
Windows NT.
Actually, I once went through the beginning of PCI DSS approval for a startup. I left before we finished it, but the point is, we realized at some point that the requirements there are actually aimed at the 30 lower percent of IT organizations, the ones that will use the same common password for everything. And actually, we had, if we wanted to comply with it, we had to actually downgrade the level of security in our network just to comply with it. So we segregated it to a sub-network.
That's PCI version 1, 3.1 is common.
Yeah, so I'm talking about 5 years ago.
Yeah.
I would like to make another point. How many of you have made the relationship between IoT and superintelligence?
Sorry, what was the question?
How many of you have made the relationship between IoT and superintelligence?
Talk about Skynet?
Skynet. Scare, whatever. Superintelligence can only exist if there is IoT providing them inputs and some outputs as well. So it's fundamental to have, extreme security focus on IoT, because otherwise the superintelligence cannot exist, or cannot be reliable, cannot be trusted. I don't know, to me, security is in my genes. I am so amazed to see that today nobody mentioned about HSM. Microsoft mentioned about UEFI, mentioned about TPM. Nobody just rehashed about this, how important it is. I said, are you mad or what? Or I'm mad? I don't know. So the question is there. Security principle exists, the technology exists, just the hygiene and the awareness is not there. Maybe IoT will help this to happen, because it's going to be so huge.
Mobile phones made it worse.
Yes.
How can
Yeah,
something
but you're pessimistic. We are engineers, we build solutions.
We're geniuses, the public are not.
Maybe the solution that you want is not here, so maybe we need to build it.
So it's an education point. So how do you educate the public?
I think I raised that UBIT protection rating point.
You get simple things like ISP accounts. I've owned ISP companies for the last 16, 18 years. The number of times people's email has been compromised simply because they have passwords like, password 123. That's the most common password. Their birthday, all that sort of thing, and they have a Facebook account with their birthday on it. And next thing, my email's been hacked, But we enforce policies, security policies that people hate, where we generate 32-character non-dictionary passwords with random characters and upper and lower case and numbers and safe characters, and their password gets changed every 2 months. That's not often enough in my book. But
I'm always really conflicted about how I feel about passwords. I mean, I follow really good password security. I use, a password manager. I use YubiKeys. I use strong passwords everywhere. Password reuse doesn't happen pretty much ever. But I still think maybe passwords aren't the way forward. Maybe it's all about biometrics. But I'm horrified at the idea if a threat actor got my biometric data, because I can't change that. My company has my biometric data. Most data centers I've worked in have it. The government has it, and that really scares me to know that the government has that data.
So here, I mean, a lot of the stuff when we talk about security, and a lot of it comes up and you go, oh, but it's also hard to do security, right? How hard is it to break into the system?
To my system?
To any system, like other systems.
Oh, if you've ever worked in pen testing, you know how ridiculously easy it is.
You go on Google search. You can even go and buy your own kit and go and do it. They tell you how to use it.
Absolutely.
Yeah.
When I moved house last month, and in the week it took my internet to arrive, I hacked all my neighbours' Wi-Fi's through simple packet injection.
Where do you
live? Where do you live?
Pass
the time. I'm quite knowledgeable in the password space. I've done a lot of very, very large password auditing projects. And I'm also in the position of trying to audit or trying to get a very large user base to change their password requirements. And so you go on, like, who do you look for the source of trust? CBA, Westpac, these guys, right? Big Four, banks. So I looked online. What's their password requirements? You know what it is? 6 digits.
That's right.
No special characters, no uppercase. How do I go to my user base in financial services and say, you guys got to have a 10-character complex password, when CBA turn around and say, you know what? Our security systems are so bloody good, we don't give a shit what your password is. Because that's what they did publicly. You can't win.
It's a custom.
It's because they've got insurance and they've got every bloody technical security control and policy and procedure in place to protect their money, and it's sure.
It's actually more business than that, because they know it's not that secure, but the business model would prefer the user to have a simple access, and they will cover the cost with the tax on the entire user base. So
acceptable risk.
What's scary for me is, we're talking about.
So much as it's cheaper.
It's
acceptable.
They've accepted it.
So then
what's scary for me is that we're talking about things like passwords and basic stuff that we can't even get right still, and then if you then draw it down to IoT, that's even more primitive, more basic. You've got to do more stuff from scratch. Standards are still just barely emerging. I'll definitely agree with the comment that it's a bit early in the enterprise for IoT, where there's a lot of like choose your own adventure type, things we're going to see. And I think as it becomes more adopted, I think we're going to obviously see some big issues before real good standards emerge and best practices and good patterns.
Yeah, I mean, just going back to that biometric things for a minute. I'll throw this comment out there, but what I've been seeing is that voice biometrics is becoming back in fashion. Because a lot of smart devices and different, integrated channels, so from phone, IVRs, and mobile type transactions, and there's a lot of different use cases that how to use voice biometrics that I'm seeing. It's an interesting development that something that I think wasn't touched much previously. In the last few years, I've seen becoming quite fashionable again. So interested in anyone's comments on that or. Opinions.
I think there's a lot of things bigger than this. I know certainly internally we've gone very much moved to form factor authentication. So very rarely do we actually ever put in a password. We're kind of moving away in general. Certain things like Windows 10 and things like that are moving towards biometrics. I'll take your point on that. But kind of moving away from people actually having to remember passwords and moving towards a secondary device to provide some degree of authentication. But I can see there's issues with that as well.
Yeah, and there's a lot of analytics too, so you're actually looking at behavioural analytics about what people are doing.
So guys, can you speak up a little bit, because the guys at the back are just struggling.
Thank
you. So his French, he doesn't really understand.
A lot of the places are moving towards analytics, so they're analysing how people move, what they do. You guys would be doing a lot of that.
Yeah.
Right? So you can pick up if that doesn't look like the normal person that does this type of activity.
I think we had a question at the back which I'm quite scared to ask, but I'm going to.
Doesn't apply.
From
what we're hearing,
it doesn't.
Sorry. The scope for IoT within the military has been massive. There's lots of things I can think of, being ex-military myself, where IoT could be useful. I'm just wondering whether any of the companies like Microsoft and Oracle are already
Securing military networks is easy.
Obviously, the risk when you use IoT within that kind of organisation has been massive as well. So.
Securing military networks is easy. You just block everything and then allow only by exception. That is literally the easiest form of security because as we all know, the biggest problem with making our network secure is the fact that they have to be available for people to use. And in the military, you're not going to let people get onto Facebook on a secure classified network. You lock down everything, and it's only by exception that you permit stuff to
But
happen.
it's also, is the military currently using IoT? Is that interaction happening already? Is there certain things that...
Yeah, that's a company called CDM down in Melbourne that do a lot of stuff.
I can't answer that question, but there is a red dot on your chest right now.
Do you consider drones IoT?
Yep.
Well, that answers my question.
Iran hacked a US drone and made it land at a runway in Iran by spoofing unencrypted GPS signals. That's already happened. That was years ago.
Yeah.
And I know that on field they're using a lot of mesh networks and things like that, so they'll run, I'm sure they've done a lot of work around security, but absolutely they're using those types of technologies.
Yeah, but is that on the secured private out of bands network, or is that an air gap thing that sits by the side for research and investment?
It's mesh based, I'm sure they've got their encryption algorithms.
But organisations that protect nuclear warheads have got air gap networks, right? That's what they do. At least that's what they should do.
We've tracked threat groups that target air gap networks.
The Russians don't know where half the warheads are.
That was solved by the Lord of War.
But surely don't use this HTTP technology. Really close.
It's over SSL3, they'll be fine.
Alright guys, we have to wrap up now. So any final questions before we do our final bits and bobs?
Wow. We are security people in this place, so we need to tell the community what's
It's more a thought than a question, but I mean, all these applications, all these new, whatever the new technology is, at some point the market's going to decide, the market, I mean, offer and demand is going to decide what applications worth building up and developing or not. Because if there is an offer, an actual business case that turns out into dollars, well, guess what? It's going to be successful. So maybe the IoT thing is going to be like 10%, maybe it's going to be 50% of the actual application that we will actually turn out being real and long-term thing, maybe not, who knows, but it's going to be down to offer and demand at the end of the day.
No.
Ah, okay.
So it should be, right? But my mum and dad always told me that people get the government they deserve. If we learn anything from Julian Assange and Ed Snowden, it's that that we will end up, look, we should never have worried about Big Brother coming in, being imposed on us. We willingly give up our rights for the convenience of being able to find our location and hook up with Andrew or someone because we're constantly giving it away. Right? So you're right, the market will decide, but don't expect it to be an intelligent decision. It's going to be an emergent decision which is going to be the lowest common denominator.
Well, that's an all different debate, right? It's going to be like quantity or whatever. It's like it is another veto.
Last one.
Don't forget that the hackers are getting super sophisticated. Every crack they will never find.
You can get hacking as a service through the cloud these days. You don't even need to
We call it red tape.
Intelligence, so don't underestimate them. So whatever solution you put in place, imagine that they will get it.
Remember one final comment.
Yeah, go for it.
If you're going to assist a company deploying an IoT device, assume that your personal details are going to be on that device. And if you're not happy, don't do it.
Yeah. So that's a millennial thing. You know, you don't give away. The understanding is that your information is going to get away, so you just don't give it away.
Yeah.
So the latest in security RSA conference at the end of this month. Listen to it, you will be scared.
Is there any vendors offering free tickets to Vegas? Oh, LA, sorry. It's in LA.
I've seen San Fran.
San Fran, sorry. Yeah.
Isn't that one of our door prizes?
Yeah. Anyway, talk about the door prizes. Gavaz, if you want to come down, and we'll just do a quick thing. Just, I'd like to thank the panelists for coming out. Microsoft and Salesforce. I really like to thank my people employ me for allowing me to indulge and have these events. If you guys don't know, Xpand is a recruitment digital organisation. Most of all, I thank Layla in the back there. For any of you want to speak to, she's our security plan expert. please have a chance to her and all expanders who helped me today. Thank you very much.